Good morning, everyone. Welcome to the second Refresh Stakeholder Workshop. I hope you can all hear me correctly and see the presentation and the screen share. So I will give you So brief overview of the today agenda first. So I will start giving an introduction to Refresh project. We are following with some updates from the technical partners on their recycling technologies. In the first workshop, we have extensively talked about those technologies. So today we will get the most recent updates on those technologies, and we will then focus on the other parts of the project, which we didn't extensively talked about last time. So we will follow this update with a presentation from CETMA concerning new products from end of life wind turbine blades. Then a Q&A session. Then we will have the break at 11. And in the second part, we will move to the fiber reinforced concrete 3D printing, the turning waste into assets through the traceability. So we will talk more in depth about the trace block tool applied to our project. And finally, the sustainability analysis of our processes and products with the most recent results. And the last presentation will be from UCA and Acciona for the developing markets for recycling materials. And then we will close with a final interactive session, which you will have more space for Q&A and so on. Okay. I will give... Oh, chat. Please.
Hello, everyone. My name is Beatrice Pagana. I will be moderator for this interactive session. I just wanted to briefly explain and introduce the methodological approach for this session. So, first of all, thanks for connecting. This session is now recorded and it will be shared after the presentations. As you can see and probably acknowledged, we slightly adjusted the agenda because the first objective of this meeting is to create an interaction between us as partners of the Refresh project and stakeholders connected, and achieve an exchange of idea and sharing of different objective achieved, sharing of experience encountered, and hopefully at the end of this presentation we will have a dynamic discussion. As you can see, the part dedicated to Q&A, I will share my screen during the Q&A session. And if you have any question related to the presentation that you see on the screen, you can directly ask and write in the chat of this meeting, and I will put the question in the board that I will share during the session. This way, we will be sure that we won't lose any inputs, and also that if there are some double topic that repeat, I will try to make efficient this exchange. So thank you, and I will give again the floor to Daniel, starting with the introduction of the project.
Thank you, Beatrice. Okay, I will go through the introduction of the project for the ones who don't know still the project. For some of you, probably will be something you are familiar with, but here it is. This is the overview of the consortium. So we have a total of 11 partners. We are distributed in 5 countries. So we count waste recycling and manufacturing companies, engineering companies, R&D companies, and we are as RINA the project coordinator, and UCA with leading the communication and dissemination activities. So this is the project concept. We aim to, from the decommissioning of wind blades till the end products, we cover this all end-of-life remanufacturing and recycling of wind blades. As I said, we start from the decommissioning, and then we have several processes, mechanical recycling processes, thermochemical recycling processes. The goal is to give end products starting from the wind blades that are dismissed in the wind factories, and this is ruled by the traceability and decision-making tool, which is the digital tool we will talk about later, that will decide basically after a wind blade is decommissioned which route should follow, and performing basically a market check, a technical check of the blade to decide the best and suitable recycling process. So this is the whole concept. Just to give you the timeline of the project, it started in January 2023 and will end in December 2026. So we are in the, we had to go through past the milestone after the design phase. Now we are in the last deployment phase, in which we are integrating the testing demos and plans. We are performing the experimental environmental analysis and the traceability platform. So just to recall the refresh value chain, this is the project concept in another view. I mean, as I said, we start from the decommissioned wind blade. We go through the pre-treatment, so the pre-cutting, the shredding and sorting, operated by TAPNF and MTB. Then we have the recycling processes, mechanical recycling from GIST Recycling, the thermal recycling from Gjenkraft, CIRCE, and Enecolab, which leads to new materials, panels, we can recover fibers, chemicals for the thermal treatment, and energy through the gasification of dust, which dust is a real problem when you are treating composite materials. So we aim to solve also this problem. So this leads to new products and application. And today, as I said before, we will focus more on the second part of the value chain. So from the new products and so on. But we will give you a quick update on where we are in also in the recycling technologies, which are anyways the backbone of the project. So thank you for the attention. I will leave the floor now to the other partners to give you the first updates. So thank you. I will stop sharing. Okay. For those of you, no, it's a minute. Okay, Jean-Baptiste, if you want to start.
Sorry, I was on mute. Hi everybody, I'm Jean-Baptiste from ETANF company. Please to refresh. I will be fast. So we develop a cutting method in order to pre-sorting the materials on site and so preserve environment and provide some materials to other ways of treatment. So just right now, our first some evolution since the last time is that we are on a huge program, on a huge project on cutting blades of 5 wind turbines in France. Nordex 90. So we already have some dust emission reduction, please to water treatment, and also we are able to cut the different part of the blades in different dimension, in order to provide to the other ways of treatment in recycle chain and value chain of the blades. So I think it was fast, but need to be fast. Also, there are Q&A session in order to talk about other subject or something I don't talk about on the presentation. So thank you, and I leave the hand to the other value chain partners of this great project. Bye bye. See you.
Okay, so we move with the GIS recycling updates. If you want to go, Giorgio. Okay.
And we need to take away some of these.
Okay.
So, good morning to all. I am Giorgio Betteto. I'm in charge of research and development for GIS Recycling. GIS Recycling, we are the partner in the refresh project that makes the mechanical recycling of the wind blade. And so we are practically using the composite particles because the material obtained from a partners and then processed by MTB to make new kind of new products, new panels from the blade. I am sharing my just a minute. I'll share. Okay. So, are you seeing my screen? Perfect. So, as you said, we have built a new mechanical recycling line in the refresh project. We are industrial recyclers for many years. Next year we will have 10 years of industrial recycling, but GIS started this mechanical process in 2015 and granted a European and world patent in 2016. So, at which point we are? We have completed the new process line. It was installed a new medium voltage electrical cabin. We completed all the silos and feeding equipment installed. Dry and wet mixing line, forming line installed, and the press also. The GIS process requires to have a different kind of stock because mixing them we obtain better product that we reduce and particle, classify them, add a small percentage of bonding agent, and then press mold panels. Here we are showing some parts of the machinery that we have installed, and the problem of this kind of operation is that all need to be custom projected and built because there are no equipment on the market to make this kind of project. So this is, for example, the dream mixing line where we are preparing the different component. This is really well suited for the part of the wind blade that normally offer the most difficulties in other kind of recycling. When we are talking the wing part of the tip where we have a lot of material.
We don't see the slides. Sorry.
That makes another way because I don't know.
No, we can see.
Okay. So I go back to the other. Okay, let's go back then. So these are the machinery that is that's I don't know why the machinery that we have developed. I am going faster now. Okay. As I said, the question is that there are no market equipment, so we needed to design a product and build. We need to have. We have transformed one of the problem of recycling this kind of process of a very different component, because in the wind blade we have, particularly in the wind part, we have laminate high density epoxy fiberglass laminate, density 1.7. We have also low density core material that could be a PET, a polyurethane, could be of very different type at the density of 0.090. And we have transformed this problem in an advantage, because it's possible to, in our process, mixing the different components permit us to make a wider range of products, and the different composite, the different feedstock make more homogeneous process. This is the pressing, the 6,500 ton press, where it's completed the polymerization of the mixer, and where the product is transformed in a solid material. Let's show also, this is the most complex part of the forming line, where this mixed material is mixed homogeneous and distributed before the going into the press. And it's a unique machine, because normally in this field, in similar equipment, for example, for wood particle or for ceramics, normally you have very identified and separated granules feedstock. Instead, we had to grant an homogeneous of very different along all the length, so it's something that's the other side. Let's go faster. This is just to show that this is not an industrial project. This line is starting practically now in making the first production. We plan to reach a production of 700 tons a year. The machine is fully controlled by computer, and we have also all the tracing. Then later we talk more. We have a complete tracking of all the components. One of the most important aspects of this industrial production and this recycling is that we have no emission apart some dust that is always unavoidable in working in composite. But we have improved a lot our collection and filtering system, also because later we will talk that the dust could be a good piece for us. But the important thing is that we just got the results of the tests, and we are practically 10 times lower respect the legal limit for dust. For the rest, we have no. Refresh line is already making panels, making products in a faster and more competitive way in respect to the past, and we are convinced that maybe really good alternatives to MDF and plywood, and then we will show something. Also, another important thing is to have to find a way to work with to improve the fire behavior of the composite. Since most of our products are designed to construction or to furniture, and the fire requirements are important, and we are demonstrating that not only is possible to obtain a very good result with recycled feedstock, recycled material, but even that we are able to increase the behavioral aspect even with the material. Here we are seeing a propane flame on a panel made from wood blade with a special phenolic binder that we are also developing. And the most important thing is not only we have a very practically no propagation of the flame, but we have also very low smoke emission. I will stop because it's if not we can go in for several minutes. Another important thing is that these panels have a very strong insular properties. So if you see, you may see that on the front we may have a 600 or 800 degree, and on the back we may have something like 20, as you see, 20 degrees. So there are effectively no transmission of the heat, and that is mostly due to the fact that it's all composite. So what we are making with this, what we are developing with this material, we are developing formwork fully composite with the recycled material and also procured parent. But then later we'll talk more. There will be CETMA that will talk more about this. We are developing now also a battery storage system using repurposed nacelle. There are very large quantities available. And in the nacelle, we are putting, we are closing, repurposing, reusing. We are using our panels to make the new flooring and the new racks. And inside there are sodium-ion batteries, because are most well suited for long-term storage and also have not the fire risk that practically forbid to use in a recycled environment. Other application that we are already doing is using, for example, for construction, for house cladding, like this is an application in Portugal. It's a material that is ideal for this aspect because, as we have seen, very strong insulation properties, that logically always considering the density. But more or less, it's something that will not degrade, that will not absorb water, it will not rot, it will not rust. And as we may say that it's probably one of the most durable products at all, and also could be and will be completely recycled after their use. So other application for electrical equipment, again, I'm ended for now, and thanks to all for the station.
Thank you, Giorgio. I remind people connected that since we had to speed at the end of the presentation, if there are some questions or you wanted that we come back on some topic, you can just share what you want to already know, some additional comment in the chat, and we will take time at the end of each presentation to discuss. Now,
okay.
the floor to.
Yeah, next one. So please, Martin, if you can.
Okay.
Yes, hello. My name is Marcin Rushin, and I'm presenting Gjenkraft, and I will take you with my short presentation through our role and the plans in Gjenkraft and in Refresh, and after the project is finished. Just a sec. I'm trying to share the screen here. Here. Okay. Yes. Do you see that? Yeah. Okay. Now. Yes. Okay. So very quickly about myself. So as mentioned, Marcin Rushin, and I'm a co-founder and currently the CEO in the Gjenkraft. On daily basis, I'm responsible for operation of Gjenkraft, taking our technology from the lab into the scale, and responsible for building up our plant within Refresh project, commissioning it and handing over to operation. But that was a boring part, and moving now to more interesting thing which is Gjenkraft itself. So Gjenkraft is a Norwegian startup. We are located in Høyanger, one of the deepest fjord in Norway. We established Gjenkraft in 2021 with a simple but strong mission to tune end-of-life waste. Okay, just a second. We lost my presentation. So our mission was to turn end-of-life waste into usable products. We should be back, hopefully. Not.
What's the
My slides is not coming through.
okay?
No,
It was working. Okay.
Okay. Okay, great. Thank you. Yes, going back to my presentation. Sorry for the technical problems. Yes, so we established Gjenkraft in 2021 with a mission, and so our tagline said it best: reversing end of life. So turning waste mainly from the wind turbine, composite waste from the wind turbine into the next generation composite product. So behind this process, we are running with the thermal recycling process, multiple step thermal recycling process. That is a patent pending process that we have developed from scratch, together with some institutes and some universities, and now we are turning it into the scalable industrial operation. So our goal is to start up the plant with a total capacity of 3,000 tons annually, which will be proof of the concept, not the concept, but the proof that it's possible to turn composite recycling process into the scalable business, into the operation. So we are the industrial partner in the Refresh project, bringing the plant operation into the project and bringing materials to our partners. And a little bit about the concept of Gjenkraft itself. So we started up our technology development long before we established Gjenkraft itself. So already in 2020 we had developed the technology that in the lab scale, that we know how we want to turn end of life wind turbines into raw materials. So we are talking here recovering glass, pure glass and carbon fibers from the mix of resins, fibers, foams, and other components that you can find in the blades, or any other kind of the composite material. So we are recovering pure fibers from the waste. And then in 2021 we start up Gjenkraft, knowing that our technology actually works in the small scale. In 2022 we already started up with the small pilot plant, testing our technology in a meaningful scale. And this is more or less when the Refresh has came. So we have started working together with the other partners on the application, and when we started the project in 2023, we've been focusing on developing, turning our process into continue the research to make it possible to scale up from the smaller scale we had into industrial operation. So we've been focusing a lot on the development, on the engineering part to turn our research, our development into documentation based on which we were able to build up the plant at the scale. So right now we are sitting together with our partners in Hoyanger. Our partners had the opportunity to see our plant, which is at the end of commissioning. So very soon we are starting up our operation with the 3,000 tons capacity, which still sounds like a small amount compared to the amount of the blades waste we're expecting to come in the future. But this is just a startup. So our plan, we have a big plans, and we will not stop at the end of the fresh project. So after delivering our plant operation, proving that it's possible to operate in the industrial scale and have a positive business case of running this plant, delivering good products to the market, meaningful products, turning yesterday waste into tomorrow's new composite products. We will continue development. We are planning to scale up our operation to 5 tons, 20 tons, and ultimately into 100 tons or maybe beyond operation across the Europe in the multiple locations. So we have big plans in front of us. So we want to transform the European economy or the composite industry in a way that the recycling and the use of recycled products is no longer an option. This will be a default way of treating the composite waste, like is with the plastics today or the kind of materials, metals. So that to prove and make it possible for everyone to recycle their waste, the composite waste, end of life products, the production waste into new materials that will go into new green products of tomorrow. Yes, thank you. That's all from my side.
Thank you, Marcin. Okay, we move now to Enecolab. You want to?
For the introduction, Daniel. I'm Carlo from Enecolab, basically for Enecolab. It is a startup located in the beautiful city of Muggia, near Trieste, and it works on producing high temperature pyrolysis reactors and also developing patents on it. Now I'll be sharing you some slides. Hope you can see them. Okay, yeah, okay, perfect. So in the framework of the refresh projects, we're working on dealing with dust and fines, which is the end product of many of the work that we do throughout the process of end-of-life wind turbine blades recycling. So each of the process, like cutting, shredding, and so on, generates dust and fine, which are composed of course, very small fibers, which are practically very low value. So our goal was to turn them into something of value, of course, which could be energy. In our case, we decided to go through high temperature pyrolysis to obtain syngas as the main product and inerts as a secondary product. In this kind of reactions, usually a variety of product is obtained, like gases, char, liquids, and inorganics. While focusing on high temperature, we make sure that the gases are the main output of the process, of course, and char and inorganics, while we minimize the liquid production, since liquid tend to have a higher degree of chemical complexity. So focusing on gases makes it easier for the end user to actually use as an energy carrier. Of course, after the pyrolysis, the gas dump came out already clean and everything. So we go through syngas purification through our technology of scrubbers that we have developed. And also the char, since we have to work at roughly 800 C, we do have to have some post treatment to obtain clean inorganics inert, which can be either used as a filler or just as a byproduct. Here is a picture of our one module of our industrial scale reactor. And on the right, you can see a comparison between the material they worked on, or which is like this dust and fines, compared to a material we worked on in the past, which is, let's say, more forgiving as it is wood-based. And you can see that we have achieved on both cases we have achieved a higher okay, sorry, 1 second. We have achieved a higher than one okay, I have it. A higher than one conversion efficiency on the energy. Using for the wind turbines, since they have a higher amount of inorganic compounds, mainly the fibers, we get 1.3 energy generated over consumed. While, for example, for another more forgiving, as I said, materials such as this HPL, which is the liquid powder from wood laminates, we can reach up over 2 times the generated. And this time, the feed rate of the fines is at 7.5 kilograms per hour. But we plan on increasing it with our further revision of the reactor, which can improve the amount of material that we can feed through by limiting the agglomerates that can form inside of the reactor. And next, I will show you a mock-up on how this technology that we developed at Enecolab works. Basically, our idea is to have a modular system that can be tied together. For example, here it is a battery of 14 reactors working all together. And of course, the amount of reactor can be tailored on the amount of feedstock that a particular project will require. So to conclude, a brief summary, we were able to develop this technology through 5 revision on the industrial scale reactor and 3 revision on the lab scale reactor, a technology that can effectively convert this waste of the waste basically into usable gas and inert solid. Doing so also minimizing the actual amount of mass that was a waste before, and it works through waste to energy system, and that can be, of course, very well integrated into already existing facilities. Thanks again for your attention, and of course, if you have any question, you can leave it in the comments, and we can discuss them later. Thank you.
Thank you, Carlo. Okay, we close this round of updates with the CIRCE.
I'm gonna share my screen.
See there is which one.
Okay, thank you. So this is Gonzalo from CIRCE Technology Center. Our main development technology is focused on the microwave-assisted technology. At this stage of the refresh project, we are focused on the comparison between the use of microwave-assisted technology and the conventional heated technology. To do so, we count with two different experimental setups that you can see in the screen, composed of a tubular reactor, and they both are capable to achieve 1,000 and 200 degrees. Currently, we are working with glass fiber reinforced polyester composites, studying how the influence of the recycling technology can influence on the product distribution we obtain after the recycling of the composites, but also the energy demand that the process demand. In this screen, we can see the design of experiment that we are currently doing to better map the influence and of the main parameters that influence the project, that are the temperature, but also the feedstock and subsector ratio. In our case, we work with silicon carbide to better heat the sample. And the objective is to evaluate the influence of the temperature and feedstock ratio on the product distribution and the energy demand, while minimizing the subsector usage, while maintaining the effective heating conditions that we need to perform the experimental reactions. That's all from my side.
Thank you, Gonzalo.
Thank you. So we are on schedule. We're just 3 minutes before the next presentation. So I would like to thank you, the people that wrote in the chat. I see that already was shared reference to another project, EcoBulk. I think that this would be an interesting point to raise at the end of the session, because the Q&A session will be focused on looking forward, next steps, and other solutions that can be used to structure a discussion. So I don't know if there are some specific questions related to the presentation shared. Otherwise, I think that we can give the floor to the next presenter.
Sure. Oh, those two questions right now. One is for Martin. Yeah, we were sorry, it's on the question. So for Martin, how much is the energy requirement per kilogram waste of your process?
It depends which process we choose, because we operate both the batch and the continuous. So I don't have the correct number in my head now, but we are running when we run the continuous operation now. We will use approximately 300 kilowatts per 400 kilo of waste, more or less. The exact number we will receive after we start up the plant and run the waste with some volume. So this number is more or less based on the work on the smaller scale, which usually is overestimated, because when we run a continuous bigger volume, then usually the energy consumption should be lower.
Thank you, Marcel. And I think this one also, the plan for 2036 is 100 kilotons per year, or
it's the same volume, so it's 100,000 tons per year. So K means 1,000, so 100,000 tons per year.
Yeah, I think it's the same.
And it's this is, let's say, our strategy to grow to that kind of capacity, but it can be lower, it can be higher, depends of course on the market, depends on the manufacturers.
Okay, thank you, Marcin. I don't see other questions, so we can move to the next presentation from Andrea Tinti.
Yes. Let me share my screen, and please let me know if you can see in full screen mode. You can see my full screen?
Yes.
Yeah? Okay. So good morning, everybody. My name is Andrea Tinti from CETMA. And I'm presenting the work done in the Refresh project as regards to the development of new products from end-of-life wind turbine blades. Just a couple of words about the CETMA, that is a private research and technology organization based in Brindisi, Southern Italy, who offers contract research and advanced engineering service on different areas, in particular the advanced material and processes department, where we CETMA's participated in Refresh project, has been working on polymer and composite materials and related technologies for over 30 years, since 1994. So we have seen that Refresh project deals with both recycling and repurposing circular economy strategies belonging to the so-called end-of-life approach. On the other hand, the most preferred option in the waste hierarchy would be the prevention of waste. This can be obtained by means of a proactive approach known as eco-design, including a range of strategies designers may take to improve the environmental performance of the product. And Refresh has the opportunity working also on eco-design by applying this approach on a wide range of new products from end-of-life wind blades. So in this framework, the role of CETMA was likely to coordinate the development of new products for several application sectors by using eco-design methodologies. During this presentation, I share key insights on 3 representative case studies working on. So with application of secondary raw materials from thermal recycling with the partner Gjenkraft, application of secondary raw materials from mechanical recycling together with the partner GIS Recycling, and repurposing of blade portions with the partner Enecolab. The fourth case study, applications in concrete structures, will be covered in a dedicated presentation later on this morning by the partner Enecolab. So let's start with the first case study, that is about thermal recycling. This is a very multi-partner case study, including not only Refresh partners, but also external stakeholders, so allowing to build up a full product supply chain. Within the already mentioned Refresh value chain, the developed solution was first to turn the Gjenkraft thermally recycled glass fibers into a semi-finished material, then to be used as a part of a new wind turbine blade component, so in a really closed loop approach. But let's see a few details more on this case study. First of all, non-woven products, a non-woven mat in particular, was developed based on thermally recycled glass fibers. The processing approach was based on a clay and thermobonding technology to get, thanks to the collaboration with the Italian company Cormatex. With respect to traditional needle punching, thermobonding relies on the adhesive effect of a thermoplastic binding. So this can help when using recycled fibers where the thermal treatment at high temperature could have caused material embrittlement. Well, then the possible application on the recycled mat of a sizing coating has been studied. The sizing of glass fibers, of course, has been lost during the thermal treatment, and it could be useful in enhancing adhesion with resin in a new composites. We used a formulation for epoxy and the related treatment procedure at laboratory scale, and the effectiveness of this treatment was evaluated by mechanical testing of laminates, of composite laminates manufactured with and without the sizing applied. Then, with the produced non-woven mat, the vacuum infusion process of both flat laminates and more complex shapes was studied. This is a manufacturing process of great interest in many industry sectors. Mechanical properties measured on infused laminates based on our recycled mat were found to be very close to commercial virgin glass fiber matte laminates with similar features, thus confirming the good residual quality of the used pyrolyzed glass fibers. As a matter of fact, in this case, we no significant effect of the sizing was noticeable, but it was probably due to the low glass fiber content in the laminate that you can see was below 20%. So the expected increase of laminate strength is in the range of properties standard deviation. Well, non-woven products can have a number of applications, but closing the loop in the wind energy sector would be the best possible result. This is why our non-woven mat, our recycled mat, was used as a non-structural element in a new wind blade layup, as discussed with the Irish manufacturer Enecolab. In this picture, you can see the selected wind blade, 13 meters long, and related structure, where the inner and outer skin of both shells, now manufactured using a virgin 3-axial glass fiber, is not considered structural and could possibly be replaced by a recycled glass fiber mat. So a full-scale wind blade section was manufactured by Enecolab by using the vacuum infusion process, demonstrating that the possibility using our developed recycled mat into an existing product without any change in the manufacturing process. The prototype has been exhibited at the JEC Innovation Planet this year, receiving a lot of interest. The solution has also been applied at the 2026 Innovation Awards of the European Association of Research and Technology Organization, CETMA is member of, with a final award ceremony will be held in Brussels next month. In the 6 months remaining of the project, the refresh will end at the end of 2026. Numerical validation, life cycle cost analysis along the whole value chain of the product will be carried out, and possibly further details could be shared later on through the project newsletter and other communication media. Well, moving on to the second case study about mechanical recycling, probably this is the one currently closer to the market. This is about application in building and construction of mechanically recycled composite panels. Again, the project value chain helps making clear the workflow. First of all, as reported during the previous presentation by Giorgio, the mechanical recycling process developed by GIS Recycling leads to semi-finished flat panels with varying composition, density, and then mechanical properties, possibly to be reinforced with fiberglass skins in a sandwich structure. So several types of GIS mechanical recycled panels were selected as candidates for the intended application, and they were mechanically tested. Based on results of material testing, the sandwich panel was found to be the best solution for new structural application loaded in bending as the one we are working on. In fact, frame formwork for shaping vertical concrete walls and columns was the selected application for this case study. The concept basically is to substitute the outer sheet traditionally made of plywood by means of a GIS recycled panel reinforced with fiberglass skins. Vertical formwork have specific standards to comply with, defining the most important performance parameter, most of all the so-called maximum lateral fresh concrete pressure that in turn reflects the maximum height of the fresh concrete column and the surface flatness tolerance under pressure in order to avoid rounded structure. For both parameters, the target values we aim to are highlighted in this slide. So again, an numerical study has been developed to design a vertical formwork based on GIS reset panel. The structure of the formwork element is reported, made of a frame and a sheet. For the sheet, the sandwich panel with varying skin thickness was considered due to its higher flexural properties as reported. For the frame, both traditional aluminium and commercial pultruded profiles were evaluated in different number and geometries. Then, to model the process of concrete pouring, a static pressure was applied normally, corresponding to a fresh concrete column of variable height, and the autoplane deformation were numerically measured, mostly affecting the sheet rather than the rigid frame that always resulted quite unaffected. So in the end, virtual testing allowed to optimize the constructive parameters to get the required performance, basically the permitted pressure and deformation. So what's next in the last months of the project? The manufacturing of the formwork elements is in progress by GIS based on the optimum numerically modeled design. Experimental validation will be carried out first at CETMA laboratory scale and then possibly to real testing on worksite environment. The third case study is about repurposing. We have seen that Refresh project explores both recycling and repurposing strategies for end-of-life wind turbine blades. Repurposing means reusing an existing part of the blade for a different application. In respect to recycling, repurposing is considered a better option because needing only minimum reworking, basically resides or reshading. As usual, a sketch is reported of the value chain related to this case study, showing that the final product with application in urban furniture does not originate from recycled materials, but rather directly from the process of blade dismantling and cutting into large sections. Okay, with regards to repurposing strategy, Refresh aims to explore both the traditional and an alternative approach. The traditional approach is to repurpose full blade section as they are. There are already examples of wind blade section with full turbine blades being transformed into playgrounds, bridges, shelters, and other urban furniture installation. On the other hand, the segmentation of the blade into construction elements like beam and panels with standard size and accuracy has been recently proposed as an alternative repurposing approach and reported to allow diversifying potential application. So, the first repurposed prototype is a picnic table. This was a reproduction from the authors who proposed the alternative repurposing approach I mentioned a moment ago. The structure is made of balsa fiberglass sandwich panels recovered from wind blade parts as flat as possible. And to join together the different recovery routes developed within Refresh, a recycled panel was produced by GIS with the mechanical recycling procedure and added as the top of the picnic table. This prototype has been exhibited at the JC Show 2025 edition. In the second part of the project, instead, CETMA worked on the development of the Refresh original repurposed prototype. The general idea was not to limit our attention on urban furniture items with just, let me say, self-supporting features like tables, shelter, and so on, but to try exploring more structural application that could take advantage of the residual mechanical performance of end-of-life composite components. So we proposed a cash cushion. Of course, there are specific standards to comply with. Accordingly, cash cushion shall be tested under certain impact test criteria that in turn define their performance level. Then a numerical study has been developed to evaluate the technical feasibility of this concept, that is a cash cushion based on a number of sections recovered from end-of-life wind blades. As a reference blade model, the already mentioned wind blade by Air Composites has been used, 13 meters in length, very well known in geometry and constituent materials. In particular, the highlighted section was considered about 80 centimeters wide, with sides in the range of typical cash cushion dimension. It's worth noting that because using a full blade section, this can be considered a traditional repurposing example. Well, then a virtual crash test has been preliminary run considering entry-level impact conditions, that is a vehicle approaching frontally at low speed. A number of different configurations were analyzed that are reported here in top view by changing the number of blade sections, their position, the way they are connected to each other. And okay, an example of virtual crash test is shown inside view first, and then also in top view. Well, the output of virtual crash test, the graphs reporting velocity and acceleration versus time, so allowing a direct comparison with the limits reported in the related technical standard already mentioned for the so-called vehicle impact severity indexes. So based on results of this analysis, we were able to define the optimal cash cushion configuration. What's next in the last part of the project? We'll replicate virtual testing on cash cushion made of tip sections from longer blades, much more common of the small blade by Air Composites. Basically, we'll have the same size and shape of the section, but a stronger internal structure. So we should be able to use a lower number of sections to get the same stopping power of the cash cushion. We also are going to physically assembly a prototype by using a number of sections recovered from 45-meter long wind blades that the partner ETANAF is dismantling right in this period. No real testing will be carried out for validation due to high cost and complexity of real crash test. This prototype will be a very preliminary, most of all communication-oriented demonstrator of the application concept we are working on, opening the door to future in-depth analysis within dedicated project, possibly involving sector stakeholders, for example, road restraint system manufacturers. So, to conclude, the mission of CETMA was to turn refresh technologies into new end products for different applications and having high ambitions in economic, environmental, and as well as technical performance. What I wanted to outline this presentation is that with today's knowledge and technologies, recycling and repurposing of end-of-life composites are established technologies that must replace low value-added waste management routes like energy recovery or waste landfilling. The market is ready for new products like those reported today, and plenty of other solutions can be conceived when industry, research, engineering association work together with the common objectives like we did in Refresh project. So Thanks to all research partners for this great journey together, and thanks to all the audience for your attention. That's basically what I wanted to share. Any question or comment, I'll be happy to answer in the dedicated Q&A session. Thank you.
Thank you, Andrea. And yes, this is the moment for the dedicated Q&A session. So I would ask if there are some question or comment strictly related to your presentation. Otherwise, I will switch the screen to the Miro board and start a discussion. It seems that there are no specific questions. Or so, since in this part of the meeting, many technical aspects related to the recycling of end-of-life waste. So now I will share the board. Okay. So I just okay. Now I will zoom. It's just to show you how we decided to structure this board. You can see that we divided. The idea is to drive the discussion by 4 different thematic areas. You see technology and scale up. So I think that this can be interesting to address questions and topics now. After that, the other 3 thematic areas we proposed are related to policy and governance, which means everything that can be related to regulation or challenges or achievement in terms of governance or stakeholder engagement or policies. And I think that these thematic area is quite connected to one of the 2 questions that was made at the beginning of the session. Then the other thematic area regards sustainability and societal aspects. For these also we will have a presentation dedicated after the break. And then the 4th thematic area regards the challenges or can include any comments or specific question related to market perspective, business, and etc. So since I don't see any specific question, we can use on technology and scale up. I think that this is a quite interesting question and something that it can really interest because it could be insightful to have some technical explanation of concretely how the transition happened from something that is planned and is it starts on a lab scale, how this transition happened when it turns to industrial scale. I see that this was something also that related some of the comments put in the chat before. So I would give the floor to one of the partners who want to briefly comment on this topic.
Sure, I can go on. Carlo from Enecolab. As you've seen before from the presentation, we had 3 revisions of our lab scale. Now we are on currently our 5th revision of our industrial scale reactor. So we basically worked on this exact transition here, moving from lab scale to industrial scale. And of course, we have to face lots of challenges doing that. I would say like the the main challenge is definitely heat transfer, because when you work on lab scale, you most of the time work on thermodynamical equilibrium. So basically, it's roughly independent on heat transfer. While when you move on to the industrial scale, it is very heavily controlled. Like the reaction is actually heavily controlled by heat diffusion into the medium. So that is a big challenge we have to face. And like another one, which is more depending on the actual material, for example, treating fibers, they have many challenges. Like, for example, we're blocked at the high temperature from the sintering of the fibers, while at the lower temperature from the agglomeration of the oils and tars. And in the transition from lab scale to industrial scale, actually, since the fibers were more let's say similar to the helix path of the transport way you're using inside the reactor, the lab scale actually was a bit worse. It had lower efficiency compared to the industrial scale. So this is something that you don't see every day. That you're actually you have more difficulties in the lab scale than compared to the industrial. But yeah, for the heat transfer, we have a patent currently in filing, which can address the heat transfer, and is able to give us that higher than 1 energy efficiency, as you saw before.
Thank you.
Thank you.
Someone want to add anything, or? And maybe we can switch to the aspect related to long-term durability.
So here I can answer. I can answer for this. I'm Giorgio Beteta from GIS, because we are making panels from recycled composite panels from many years. So we are seeing that really. So first we needed to understand the real durability of composites. We are recyclers of composite, and so we receive material at the end of their life. Currently, the oldest material that I recycled were two kinds of products. On one side, electrical equipment from railways, molded from probably RTM polyester molded, dated 1954. So when we received it was already more than 70 years old, of continuous use in outdoor, because are practically structure used for insulator parts of railways. And what we have seen that practically show really no degradation, no thickness where analog to the original part. And the other material that we received very old, it was with the milestone H2020 project that we done, a fiberglass motorboat collected recovered in the Venice Lagoon from an NGO. A boat built in 1968 and abandoned in the Venice Lagoon since at least since 1984, because in 1984 in the first aerial photos it's already present. So at least 40 years outside after the construction abandoned. Again, we have seen this practically the fiberglass parts are nearly indestructible and nearly last forever. The problem are where there were wood inside because the wood tends to rot and expand. The products that we made have more or less the same behavior. We have already did several tests of accelerated aging and so on. So I think that there will maintain the durability of the composite product. I see that there was also another question regarding the end of life of the recycling panels. And here I think that we can show, and I can show a short video that may tell more than a block photo. So this is our production line. These are panels that are practically the offcuts of our customer. They send back to us the offcuts that will be recycled in the normal product. For us, it's good because we have selected feedstock. Our customers are happy because they don't have they have less problem respect and so on and so on. I think that this will be mechanical recycled exactly in the same way that it made.
Thank you, Giorgio. Okay, we have the last 5 minutes. I see one question in the chat. Okay, I put this question on the board because the right person to answer this is momently absent, but I think that
I can answer to the second part of the question.
okay.
We are currently one of the reasons of building the new production line. It was that of reaching an output that make it possible to have a competitive product with plywood. Currently, we are thinking that we will be competitive with the plywood with the same performance of also a marine plywood and a fire treated plywood. We probably will be even a lower cost.
Thank you, Giorgio, for addressing this. I am just putting the question on the board, so when the person arrives, we can. Hello.
Something new question.
So, Rafael, I am writing one of the questions that was made on the chat. I don't know if you have a comment on this.
There is a lot of questions here, right?
Yeah. There are 3 questions, but maybe you can answer to the first one. What is the regulatory framework status?
The first one in our presentation, we will cover. There is a few initiatives, but I can already say that the Net Zero Industry Act is covering this on the public procurement, how to increase, let's say, sustainability approach especially for the blades and the renewables. The second, cement processing considered recycling or not. We truly consider ourselves co-processing as a recycling process, because in mass, I don't want to go much in details on cement process or co-processing means you take the end of life of the blade you shred it, and then it goes to the cement kiln. So in volume, in mass, 70% of the ingredients are glass and filler, and they are in the composition of the tanker of the cement. So 70% is recycled, and 30% is valorization, because the resin is, of course, the what they call alternative fuel. So at the European level, it's not yet considered as a recycling process. We are working on it, and we have also made an LCA study to demonstrate the value of this co-processing, together with some other associations partners. Of course, there is some activities, and we will develop more later together with on the Circular Economy Act, which really will enforce this. And just a live example is the end of life of the vehicles. So it's not the blades, but it's just to tell you where the trend is on the regulatory framework. The end of life of vehicles, which will be published within the next weeks now, in fact, force the automotive car manufacturers to use 25% of their plastic has to be recycled, has to come from recycling. So that's this type of targets. Of course, sometimes you could see it as a difficulty, but it's an opportunity also for to pull the secondary raw material markets. That's so. What about economy? Okay.
Yes, I think that the rest of the
is it okay?
Yes, thank you, Rafael.
Yeah.
You, Giorgio.
Yes.
There are some.
Yes, I have already answered. Yes, we are able to recycle carbon fiber waste. In fact, our process may process any kind of composite regardless of the kind of fiber or resin. So in this period, we are focused particularly in recycling of mixed carbon fiber, glass fiber prepared, for example, or carbon Kevlar prepared, because are much less interesting for who is doing the thermal recycling for recovering the carbon fiber.
We have 2 minutes left.
Yeah.
Okay, now we are including the reference for MTB recycling. Now we have another question. How do you manage the metal content in the waste?
Question to who is the question? The different recyclers manage it differently, I guess.
I think the first that wants to.
So for us in this, we have metal. We have magnetic metal separator, magnetic metal separation for ferrous metal before the threading and also after, plus non-metal eddy current separation before the granulation.
And from our side, we do separation of the metals up from the process, and during the process, the remaining metals that are not possible to be deattached before processing are removed. Since we are decomposing the resins, then all the parts or the components are getting loose, so it's easy to remove them from the outcome.
See, raise that from Jean-Baptiste.
Yes, can you hear me? I'm just answering on the chat, but enough when we are cutting on site, we are pre-sorting the metal parts of the blades containing in the root part of the blades, attachment part, studs. And after that remain only the cable, the copper cable along the blades for the storm issue of the blades.
Thank you very much. Okay, we are on a schedule. Now we reserve the 15 minutes for a short break.
Yeah.
So the link will remain active. We just close the microphone and we restart at 11:15 with the presentation from Technalia.
Thanks.
Thank you very much.
See you later.
Thank you. See you later.